Thank you very much again for your nice introduction. And my name is Hak Lae Lee from Seoul National University. And it is my great honor and pleasure to have an opportunity to present or introduce a little bit about our research on nanocellulose, which is entitled The New Bioresource Materials for Future Society. And first of all, I would like to introduce a little bit about Seoul National University. It is in Seoul, Korea. When you travel down south, you will come up with a mountain Ganak, which is right here. And at the footstep of the mountain Ganak, Seoul National University is located. I enjoy this place because we can enjoy surroundings of nature that changes all year round. At this time of the year, we can enjoy the colorful change of the trees. In wintertime, of course, we can feel the silence and relaxation feelings that Mother Nature gives us. And Mother Nature has been made for us because in the beginning, God has created everything around us. But there are some people who does not believe God has created everything. These people say that God has not created one thing, and that is plastic. In a sense, it is true because we humans exploit the oils from the oil well and distill it and modify it and synthesize it into polymetallic form to make plastic. And humans have found that the plastic are so versatile, strong, rigid, flexible, cheap, colorful, moldable, and many other things. So we use it day and night. You use it 7 days a week and season by season. So all year round. So now we come up with, realize that, there are so many plastic garbage all around us, on the land, in the sea, even in the air. So it is time for us think about these challenges of removing the plastic waste. This is the minister of the Saudi Arabia who served as a minister of the petroleum and mineral resources. He mentioned many years ago that the Stone Age did not end for lack of stone. And the oil age will end long before the world runs out of the oil. Yes, the Stone Age did not end for lack of stone. We still have a lot of stones around us, but people never use the stone for our daily lives because our ancestors have found something far better than stone. So if you do not like the plastic that around us, so many places, it is time for us to find something else. But it must be better and in performance, in quality, and for our environment. And here is a saying from William McDonough, who is a pioneer about our sustainability issues. The Stone Age did not end because humans ran out of the stone. It is the same wording, but it ended because it was time for rethink about how we live. Yes, I think it is time for us to revitalize the use of bioresources because we know that everything God created is environmentally friendly and sustainable. And nowadays we realize that God did not create plastic because it is not decomposable. So it has damages to our environment. And I think there is very few countries that can solve this kind of challenges. I think Indonesia is a country that has a lot of capability to meet the challenges of today, not only because of its size, not only because it is many resources available in Indonesia, but also because you have a lot of young generations and peoples who have a desire to make the changes and the dedication to achieve the changes. And today, I would like to introduce some of our research efforts to use bioresources materials as the substitute for petrochemical products. So we have spent many years studying nanocellulose, which is one of the most prominent green materials of modern times. It is very attractive and excellent, has excellent characteristics because they are abundant and renewable and most of all biocompatible. So by using this CNF obtained from the trees or sometimes from bacteria, we can produce many products for our daily lives. Here are some statistics about the importance or the of the nanocellulose. According to one report, the compound annual growth rate of the nanocellulose market will be around 20% from 2020 to 2027, and it will reach $1 billion in 2027. So it has such a huge market in the future in many diverse areas of applications, ranging from the cement composites and paper and packaging and food product, etc. Because of this, potentials of nanocellulose, you can find that number of papers or articles or literatures that have been published recently. So nanocellulose can be divided into three main groups. The first group is nanocellulose nanocrystal, which can be obtained by selective hydrolysis of amorphous cellulose regions. And the second category or second type of nanocellulose is called cellulose nanofibril, CNFs, which are mostly produced by mechanical, chemical, or both application of both. In the case of bacterial cellulose, there is a specific microorganisms that synthesize 100% pure cellulose from it. And in this presentation, I am going to introduce some of our research efforts about the CNF. There are two main areas of research. First of all, the production technology must be developed to produce the nanocellulose with a low energy consumption. And we have to find a way to produce it environmentally friendly way. And we also needed technology to improve the properties. And there are some other areas of research, how we can use it for our industry. And I'm going to concentrate in the second topics, the application technologies. And here is the three main topics that I'm going to share with you today. And first of all, I'm going to talk about a little bit of our research on thermal energy storage system additives. In the second section, I'm going to say something about the use of nanocellulose as a sensor manufacturing materials. At the last section, we are going to share some information about the barrier coating properties of nanocellulose. So first, let's take a look at the thermal energy storage systems. This is an example how we can use the thermal energy storage systems. The thermal energy storage system is the technology that stocks the thermal energy by heating or cooling a storage medium so that the storage energy can be used at a later time for heating and cooling applications. So for instance, if you place the thermal storage materials on your rooftops of the house, during the daytime, the sunlight hit the materials and increase the temperature. This solar energy will be stored in your phase-changing materials as latent heat. And during the nighttime, this liquid phase-changing material will solidify and release the stored latent heat. And you can use this kind of latent heat as a source for heating of your house. So this is a simple example how we can use the thermal storage systems. And there are many materials that can be used to as a summer storage units, which is called phase-changing materials. And in this research, we use this sodium carbonate as a phase-changing material. And because they have a high phase-changing temperature, about 58 degrees, and very high latent heat of fusions. As you see here, however, this material dissolves in water, but after repeating, repetition of the cycling, freezing and melting again and again, will separate two phases. So to remove this kind of phase separation, or to solve this kind of phase separation problems, we apply the CNF to these solutions and found that it is quite stable without this kind of phase separations. Even make it better, the CNF will enhance the solidifying properties, or the time is going up. So, also the CNF can be used as a material to enhance the thermal conductivities as well. Okay, and we also introduced some interconnecting interfiber bonding technology to enhance the coming back shape recovery properties to the system, and use it as a holding material for the thermal storage materials, which was quite successful as well. And because of the time limitations, I'm going to skip this part of the source applications, but I'm going to go back directly to the application of the CNF as a barrier coating materials for eco-friendly packaging. So as you know that, plastic is the most important packaging materials, but it causes a lot of trouble because they never decomposes. So to replace this kind of plastic materials with biomaterials that can be decomposed and regenerated, we used cellulose nanofibrils as a potential coating materials for papers. As you see here, when you increase the coating amount on a paper, you can completely seal the surfaces, restricting any permeation of the papers or oxygens whatsoever. Also, it is possible for us to make it highly hydrophobic after treating the surface of nanocellulose with some chemicals. As you see here, CMCNF increases the air permeance such a high levels, so it is very impermeable films, which will be very good for as a packaging materials to prevent the vapor or oxygen permeations. Also, with the use of CNF with some chemical additives, it is possible to increase the many properties. Okay, here is final examples. So when you have this kind of combined use of CNF with latex, for instance, you can decrease the water vapor transmissions, and you can also increase the oil resistancy, and also it is possible to reduce the oxygen transmission rate substantially. So I think because of the time limitation, I cannot say many things about our research, but I am here to say that the young students from Indonesia, there are many opportunities, great opportunities. That is that you can devote yourself and found very proud result. And there are, as I mentioned before, there are not many countries which have such a great potential as challenge makers, but I think the audience, you can make changes for our futures. Thank you very much for your attention. If you have any questions, you can send me an email or ask me a question after the conference during the discussion times. And sorry for the hurry because of the time limitations. And thank you again. Thank you.